Good morning. Today we're going to learn about a star's brightness and try to figure out how bright is a star. This is going to be your star log. You can put your name on it and then we'll begin. Our central question for today's lesson is, does the distance from Earth affect the brightness of a star? What do you think? We're going to learn throughout this lesson and try to gather some information so by the end we can answer this question. Introduction. Today we're going to learn about the brightness of stars and how they are measured from Earth. Did you know there is only 9,096 stars visible across the entire sky? Well, that's just when you look up at night. When scientists use binoculars and telescopes, there's many, many more. Thousands more. But why is this, do you think? Well, from down on Earth, we only see the brightest and biggest stars. Once we get closer, we notice there's many more, in different sizes and brightness levels. That is what we call apparent magnitude. What is apparent magnitude? The definition of apparent magnitude is the magnitude of a celestial object as it is actually measured from the Earth. Magnitude is another word for size or measure, and celestial object is another word for star. Now you're going to make your own definition for apparent magnitude. You can type your answer below. Remember, make sure your definition is in your own words and you understand what it means. You can go back to the previous slide if you need help to figure out a definition. I'll give you some time to do this. Okay, we're going to move on. You can always come back and finish this at the end. Share your thoughts. Are stars brighter than planets? Can we actually measure how bright a star is? If you used a telescope, how many stars do you think you can see? Write down your answers. I'll give you some time to do this. Alright, moving on. Again, you can always have more time at the end if you need. Star chart. Now we're going to be scientists and figure out the amount and brightness of stars. When scientists do this, they take a sample before they start. Do you know what a sample is? Write it below if you do. A definition of a sample is a small part or quantity intended to show what the whole is like. An easier definition of a sample is a small part of something bigger. The picture on the left is a sample. The picture on the right is a full picture. Why do you think scientists use a sample when they're looking at stars? Well, if they had to use the full picture, it would take them a very long time to do this. That's why they use a sample, so it doesn't take them as long. Collecting information. Here's the star chart sample you'll use to collect information. You're going to find and count 50 stars and put them in your star chart located on the next page. Here's your number chart. The brightness of stars are labeled faint, medium, and bright, and the number of stars is where you're going to input your answers. Go through your star chart, find 50 stars, and label them, whether they're faint, medium, or bright. I'll give you more time to do this at the end. We're going to move along. Results from the number chart. So once you're done and you have all your answers, you can answer these questions. What level of brightness had the least amount of stars? Was it faint, medium, or bright? What level of brightness had the greatest amount of stars? Was it faint, medium, or bright? Write your answers below once you've completed your star chart. The last part of this lesson is a fun experiment about proving that we can measure the brightness of stars. You're going to need 2 flashlights. Cell phone flashlights work. Just ask your parents before you use them. A blank wall and another person. It could be your sibling or your parent. Now back to our essential question. Does the distance from Earth affect the brightness of a star? What do you think? Procedure and observation. Make sure both flashlights are on the brightest setting. The flashlights will act as the stars. You and your partner will both stand one big step away from the wall. It's important that you're the same distance away from the wall for the first part of this experiment. Shine your flashlights on the wall and record what you see. Next, your partner will take a couple steps back from the wall. You and your partner will both shine your flashlights again at the wall. You should be one big step away from the wall, and your partner should be a little bit behind you. Now what do you see? What's different between yours and your partner's star? Record your answers below. Using the information from both of your observations, answer the essential question. Does the distance from Earth affect the brightness of a star? Once you've completed this, if you need more time to go back and finish your star chart, you may do so. If you're all done and everything is complete, great job. And always remember, you're a star. Thanks for watching and take care.